All right. So what's today? The 23rd? Wow. Almost, golly. All right. So we are starting in section 2.1. My favorite and yours, the unit circle. This, we will be with the unit circle for a long time. Well, I don't know. We might not be for this time. But there is something specific about the unit circle. And this is like the Ohio State University. It's called the Ohio State. This is the unit circle. This is not any circle. This is the unit circle. So I want you to draw a big old non-shaky coordinate plane, and I want you to draw a nice circle on that coordinate plane. You will get up close and personal with this. You will have so much fun. All right, so here we go. Quadrants, let's name our quadrants. We already know these. Quadrant 1 is where? Tell me the direction. Top right. So Q1, and then it goes clockwise or counterclockwise. Counterclockwise for whatever reason. It has to be, I just had an epiphany. It's no such word, but it is if you watch The Office. Why does quadrant 1 start in the top right corner? Why do you think? It literally just hit me. Because it's positive, positive. Now, I don't know that for a fact, but I would assume that because the ordered pairs are positive, positive, that's why it starts quadrant 1 in that top right-hand corner. And of course, quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. The signs are going to be very important to us. It's something you already know. I get that. The quadrants are very, very important to us as well. But we're looking at our circle. And folks, the radius is going to be from the origin to any edge of the circle. Do you guys agree with that? Okay? The radius. And what do you know from geometry? Well, let me back up. The center of this unit circle is the origin, 0, 0. This is for the unit circle. You have to know that the radius, the length of the radius is 1 unit. It's 1, okay? Now, what do you remember from geometry about all radii? They are half the diameter. What else? They're all equal. No matter where I draw a radius, if I draw one here, if I draw one here, if I draw one here, anywhere around my circle, the radius is still 1, okay? Special note, all radii are equal. R-A-D-I-I, all radii. That's important to us. Now, so what am I going to do with this? The origin is 0, 0. The radius is 1. What is the basic equation for a circle? Do you guys remember this? We just have started teaching it. You guys would have been, not everybody. Most of you have just gone through the new geometry SOL, the revised SOLs, and we just have started teaching these with the new SOLs. Do you remember the basic equation for a circle? Anybody? It's this right here. Because these letters always make so much sense. X minus h quantity squared plus, do you remember the other part? Anybody? Y minus k quantity squared is equal to r squared. Okay? That's the basic equation for any circle. Now that's important to us. That's the basic equation for any circle. Now, you got some other letters up here. What are the letters that we recognize from other equations we've used before? The X and the Y. That's kind of standard, okay? But we got these new letters. The center, for whatever reason, are the letters H, K. What do you think R stands for? You already know. R is radius. Okay, the radius is R. So X minus H quantity squared plus Y minus K quantity squared is equal to radius squared. That's the basic equation for any circle. Now we're going to derive, there's that word again, okay? This is the class that I actually get to show you why. It's not just a process. This is like, this is old school. Now we're back to old school. We don't have to be, driven by that stinking test. But we're going to derive the equation of the unit circle, okay? So, what is our equation for the unit circle? Well, we're going to use that basic equation, so let's think about it. What is, for the unit circle, the center is what? You already have it on your paper. It's the origin, which is the ordered pair, 0, 0, right? And we are told that the radius is always what? In the unit circle, it's always 1. So we're going to take that information and we're going to plug it into the basic equation of a circle, okay? So let's think about this. We're going to start with X minus H quantity squared plus Y minus K quantity squared is equal to R squared. Oh, I could so turn this into a proof. Woo! That would be our given statement. Okay? What do you think we're going to do with this information right here? We're going to substitute. Oh, that would be the substitution property, wouldn't it? Oh, how these proofs haunt you. What do I plug? How do I plug this stuff in? Where do I plug in 0, 0, and 1? The center, which is HK, is 0, 0. So I'm going to put X minus 0. And we are not going to skip steps here because we are deriving something. So we're going to show every single step. How about the radius? What's radius? 1 squared. Can we clean that up? Can I clean up that equation? Yeah. X minus 0. Folks, what is anything minus 0? That thing. So can I write what? X squared plus who? Y squared is equal to who? Oh, you better not say 2. Guess what you just derived? What is that the equation for? Be careful. The unit circle. This right here is going to be your best friend for a couple of days. This is the unit circle equation. I want you to put clouds and rainbows, ponies, and unicorns around that equation. It is so, so important. Now, I don't know if you've seen other trig students, but they have this little card that they keep with them. It literally is a half a sheet of paper, and it's on cardstock, and we add all these equations to it because it's more important for you to know how to use these equations than to have to memorize them, all right? But this is one that you should kind of like quadratic formula. You just kind of have to know it, okay? And let's face it, that's pretty simple, okay? That's very simple. X squared plus Y squared equals 1. That is the equation for the unit circle, okay? How are we going to use it? Very, 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 very important. How are we going to use it? We are going to use it like this. doing on time? So you are going to have, and you got to remember, folks, that these problems that you're doing, your textbook is a college textbook. This is not meant for, for us to be, it's not like a little fluffy kitten, all sweet and, purring. I can't do that noise, but you know how they do. It's not that sweet little, oh. No, you're going to have to use your brain. And you're not going to whine because it's going to make us tough. Tough in a mathlete sort of way, because you're all mathletes now, right? You know that. You're a mathlete. Don't even try to deny it. So, you're going to show that a point is on the unit circle. We've got to show that this point, negative 2/3, negative root 5/3, is on the unit circle. We've got to prove that that ordered pair is part of the edge of the unit circle. Now, y'all, what's the only thing we have to use right now with our little limited base of knowledge? X squared plus y squared equals 1, right? That's all we've got. Write it down. I mean, this is totally new. What do you think we're going to do? Now, let's reach here. Come on now. What are we going to do? Plug it in. I have an ordered pair. An ordered pair is x, y, correct? Substitute. Oh, another proof. Yep. Here we go. Negative 2/3 squared plus negative root 5/3 squared is equal to 1. What do I want to do? What do I want to happen here? Because I'm not solving for a variable. What am I wanting to show? That they're equal. I want to show that the left side is equal to the right side, correct? All right, what is negative 2/3? Oh, I told you how fractions are your friends. Welcome to the world of fractions, folks. We are going to stay in fraction land. We are not going to never, never decimal land. That's no fun land. We stay out of it, okay? It's kind of like Disney. I'll bring you hats later. What are you going to do with this? We're going to create hats like the Mickey ear hats, except for one ear is going to be the pi symbol. The other ear, what's the other ear going to think? What's it need to be? The pi symbol and what else? A fraction. Michaela, we're going to come up with that. We're going to make those hats in this classroom, and you all are going to wear them outside of this classroom. Oh, yeah. Here we go. Are we going to wear it in a class, and then y'all are going to walk around the class? Daniel, yes, you are. Around the hallway with your pi fraction hat on, okay? What is this? Stop distracting me. You stop it. Negative 2/3 squared is positive 4/9. You do not need a calculator for this. Use your noggin. Negative root 5 squared is plain old 5. Because think, what's negative? What is square root of 5 times the square root of 5? It's the square root of 25, which is actually plain old 5. Over who? 9. Is 4/9 plus, what's 4/9 plus 5/9? 9/9. Is 9/9 equal to 1? Yes. We just proved what? What's that mean? That this point, negative 2/3, negative root 5/3, is on the unit circle. So you just did a proof without doing a proof. Sometimes you may have to do that. Why? Because we're adding or subtracting fractions. Side note, if you get 1/3 equals 1. Is that a true statement? No. So what's that mean? The point is not on the unit circle. Very good. Very good. Okay? Attaboy. Easy, right? Very easy. Hey, so if it's a true statement, the point's on the unit circle. False statement, not on the unit circle. Here we go. Let's locate a point. On the unit circle. Because what if we are only given one piece of that ordered pair and you're told to find the other piece? Let's say you are given this information. The x coordinate is positive. And the y coordinate is negative root 5 over 5. Find the order pair. Find that point on the unit circle. Use the same little formula because that's all we have to use, right? So what am I going to use? X squared, you guys tell me, plus y squared is equal to who? 1. That's all we've got. Now, do you think it's important, because this, y'all, we've never seen problems that look like this before. The x coordinate is positive. I would write that off to the side, and it says the y coordinate is negative root 5 over 5. We're trying to find that positive root, and that's important. So what do? Plug what where? X squared, I heard it, plus negative root 5 over 5 squared equals 1, right? Yeah? Now we're solving for x. Let's solve for x. So we get x squared plus. What's the root? Square root of 5 squared. Plain old 5 over 25. It doesn't matter if it stays like that. That's okay. You can reduce it if you want to. It's going to be 6 in one hand, half dozen in the other. What are we going to do now? Move the 5/25ths or 1/5 over. I would recommend keeping it as 25 as your denominator, and you'll see why in just a second. All right, now, you do not need a calculator because 1 is equivalent to what fraction? Think 25 over 25. Remember, fractions are your friends. What's 25/25ths minus 5/25ths? 20 over 25. What now? Square root of both sides. Do you understand why I wanted you to leave the denominator as 25? You still have to rationalize it, right? And that's why I said it. 6 in one hand, half dozen in the other. You can reduce, it's fine. You can go this way, it's fine. You still have to rationalize in the end. Keep in mind that it's going to be the square root of 20 over the square root of 25. Oh. What did I forget? What did I forget? I took the square root of both sides. What did I? Plus or minus. It's very good, Carrie. Plus or minus. Now, hold on. Hold that thought. Plus or minus. All right, so let's rationalize. What's the highest perfect square that goes into 20? 4 times 5. Of course, I'm showing 43 steps for a 4-step problem. Y'all know that. Plus or minus 2 root 5 over 5. Do you guys buy that? All right, now Sarah. What's wrong with that? It's true, but do I need both of those answers? Why not? Tell me why. Because it said the x-coordinate that I need has to be what? Positive. Ha. So what am I going to circle as my answer? Positive 2 root 5 over 5, comma, negative root 5 over 5. Just for kicks, which quadrant is that point in? Positive 1, 2, 3, quadrant 4, just for kicks. Okay? Do you guys agree with that? Uh-huh. Yep. Yep. What do you think? Not that that's not difficult. Hey, what's it all boil down to? You got to know the unit circle equation, and you better know how to solve an equation. Hey, think about what we just got finished. Did we not just get finished taking the square root of both sides of an equation to solve? That's why we do that. Look at there. Look at there. How about that? Hey, I want you to do this one. This is what I want you to do. Yes, I'm assigning homework with like 2 examples. I want you to do page 120. Let's go 1, 4, 5, 6, because I just introduced this, okay? Now, 5 and 6, they're going to tell you which quadrant the point lies in. Like my problem said, the x-coordinate's positive, the y-coordinate is negative root 5 over 5. This one's going to give you a coordinate, and it's going to say, here it is, it's in the 4th quadrant. You have to be mindful of your signs just with it saying quadrant 4, okay? But you can totally do these, and don't come in here going, I didn't understand. You better understand, okay?